Hello Year 11 and welcome to Friday. Not long until we're all back together as a nice big happy class again. For the moment, let's sort out what's going on for today. We're going to be doing congruent triangles, which you did do in Year 10, but we need to make sure that we're just familiar with the terminology yet again. So let's remember, congruent triangles are identical in every way. They're the same size, they are the same shape, they have the same angles. So in your two triangles you have matching or corresponding sides, which are the same length, and matching or corresponding angles, which are the same size. Three horizontal lines equals congruence, two vertical lines is what we use for parallel, and there you can see our symbol for perpendicular lines, for lines that are at right angles. Now, just so that we've got the terminology understood, if I have triangle ABC and triangle PQR, the order of the letters is important. So when I have my two triangles that are the same, A, B, C, if I have angle A, angle B, and angle C, because the letter A is first and the letter A has a cross, the letter P must also match up with that cross angle. Because the letter B is second, the letter Q must match up with the same angle that B is, and similarly R would match up, so that the letters match up with each other within the shape, which means then the sides match up. If I look at the first two letters, A and B, side AB matches with the first two letters in this one, side PQ, and so on. If I had B to C, they're the last two letters, so Q to R, the last two letters, B to C, matches with Q to R, and so on. And if all those conditions hold, that means you've got sides that match or correspond with each other, angles that match or correspond with each other, so the two triangles are congruent. Here are our four tests that we used last year. Three sides, two sides, and the included angle between those two sides, two angles a side, a right angle, a hypotenuse, and a side. Hopefully you can remember those from last year, but we'll use them again anyhow. Here is our first example. Now with the first example you can see they both triangles have 96 degrees. But triangle ABC has a 41 degree, whereas triangle PQR has a 43 degrees. So they're different angles. So we need to do a little bit of preparation work. So I'm going to use a little bit of loose terminology here. In triangle ABC, I'm going to say angle A plus angle B plus angle C equals 180 degrees, because the angle sum of a triangle equals 180, which means I've got 41 plus 96 plus angle C equals 180. If I add 41 and 96, I get 137. And when I take away 137 to both sides, I get angle A equals 43 degrees. Sorry, angle C equals 43 degrees, so that's now 43 in there, which means it's going to match up with angle R in the other triangle. So, what do we know about these two triangles? Well, we've got the missing angles that I found. I only needed to find the 43. I didn't need, if I did the similar method, I would have actually found that one over there to be 41, but I'm not interested in that. I've got enough information. There's my rules. Which one am I going to be using? Well, I've got one side and a combination of angles, so I'll be using angle, angle, side. So the triangles are congruent by angle, angle, side. Now let's have a look at it. Angle BAC, which in the triangle ABC is the 41-degree angle, and PQR is the 41-degree angle. Really, that's when I did the example. Yeah, I probably should have listed angle ACB equals angle QRP, which both equal 43 degrees. And why? Well, we can see that. Given from the information on the diagrams. But I've used a 41-degree angle there. The 43-degree angles, yeah, well, I probably should have used the 96. It doesn't matter, you've got all three angles, so once you find them, the reason I'm saying I probably shouldn't use the 41 given what I started with is because I found the 43-degree angle, the 96-degree angle was given. I haven't actually physically shown the working out to get the 41-degree angle, so using the 43 and the 96 would have been the better of the two to use. But hopefully you understand what I'm talking about there. I've got the side A to C and Q to R, or R to Q, they're the same, which means my summary, and I need to make sure I get this right, triangle ABC is congruent to triangle. Now, because ABC starts with A, and that's the 41-degree angle, the next one starts with Q. And triangle ABC, the B is the 96, which matches up with P, and so it'll be QPR, and that's the correct order, so that my ABC and my QPR match up by angle, angle, side. Let's try the next one. Now this one, effectively, I've got to prove that triangle OTS and triangle OPQ are identical. Well, they're the rules that I've got. It's important that I understand from this question that O is the centre of the circle. Now, if I look at this, O to T is that length there, which is a radius. Because it's the first two letters, it'll match up with O to Q, which is a radius as well. So they're two side lengths, so I'm actually going to use side. OT equals OQ given because they are equal radii. Now the second thing that it tells us is that if I look up the top here, the first and the last O to S, first and the last O to P, they match up. So O to S matches up with O to P. They're the same length. They're actually the same length as the other, so I don't need double dash, but so side O to S equals O to P given because they are also equal radii. And the last one, which we'll do for this one, is we notice that those two angles are the same because they are vertically opposite. So angle, we'd have angle. Now if I use TOS, that means I've looked at this triangle here. T is the second letter, O is the first, so it goes second letter, first letter, third letter. So in the next one it's second letter, which is Q, first letter, which is O, and third letter, which is P. So angle TOS equals angle QOP. Why? Because they are vertically opposite. which means triangle OTS is congruent to triangle OQP by angle, angle, side. And that's that one. Let's move on to example number 3. Example 3, we are told those shapes are congruent. So if we're told they're congruent, if I look at the first situation, the first letter is A and the first letter is C. So the angle at A and the angle at C match up. So Y equals 40 degrees because they are corresponding, which is a fancy word for matching, they're corresponding angles. Now let's look at the next one. If I look at the angle BDA, well actually let's look at BDC. We know it's a right angle. BDC, if I look at my triangle on this side, BDC is the second letter, the third letter and the first letter. So the second letter, third letter, first letter would be a BDA. If I go back to this side, BDA must match it. Therefore, Z equals 90 degrees because they are corresponding angles. And the last one is what happens to the sides. Now A to D, first letter, third letter, A to D would match up with first letter, third letter, C to D, which means if I look at side length AD and side length CD, X equals 3 because they are corresponding sides in my congruent triangles, and I've found all my lengths, or all my pronumerals. Let's go to example number 4 now. With example 4, I have to show the triangles are congruent. Well, I do have some parallel lines, so that's going to help me. If I look at AB, so we know AB is parallel to DE. So that's given because I've got the arrows on those two lines, which means because they're parallel, I'll see some alternate shapes. If I can see a Z shape there, that means angle ABC equals angle CED. They are alternate since AB is parallel to DE. The next line of working, still got alternate angles going back this way, so I end up with angle BAC equals angle CDE, and they're alternate since AB is parallel to DE. Now the last one is going to be those two angles are equal. So angle A, oh actually I need to be careful here, falling for the trick. If I did this, angle ACB equals angle DCB. They're vertically opposite. It doesn't actually help me because then I've got angle, angle, angle. And angle, angle, angle is not a test for congruence. It's a test for similarity. So I only need to use two of those. So it doesn't matter which one I ignore. I'm going to ignore this one because I wrote it last. I need to deal with side to test for congruence. So I can see A to C is the same length as D to C, given because there's a marker on it. Therefore, and the order is important here, triangle ABC is congruent to, now triangle, in triangle ABC, A matches with D, so I'm going to have the D first. B matches with the E. You can see that from my alternate angles, and I have no choice but to put the C last. By angle, angle, side. Now the question says to prove that AB and ED are equal. Now if I look at this, AB are the first two letters and D and E are the first two letters, therefore AB equals DE, which could also be written as ED, since they are corresponding sides or matching sides in congruent triangles. And there you go, we've finished that. Let's go to example number 5. Now with example 5, it says which two triangles are congruent. Now I need to come up with some naming convention here, so because I've got 4 triangles, I'll just call them triangle 1, 2, 3 and 4. What I'm going to do to start with is, in triangle 1, I've got an angle that's across going through to an arc. So I'm just going to put a marker down that side, the cross to arc in triangle 2, the cross to arc in triangle 3, and the cross to arc in triangle 4. Let's go and pick a different colour. Now I'm going to do the cross to dot, cross to dot, cross to dot, cross to dot. Probably don't need to be doing all of this, but I'm going to do it anyhow to drive the point home. Dot to arc, dot to arc, dot to arc, dot to arc. Now I look at my triangles. The critical part is to find out which ones match up. So look at triangle 1. I can see there's a side length that's 7, and that's in the goldish coloured writing. Yeah, that will only match up with triangle 4 with the goldish coloured writing. Let's look at triangle 1, the blue side, A to B is 5. Triangle 4, the blue side is 5. All of the angles match. Oh, that's it. It's triangle 1 and triangle 4 because the angles and the sides match up. So triangle 1 is congruent to triangle 4. And it's because of the matching sides and the matching angles. It's not a proof, it's just asking you to identify it. So there you have it. Time for you to do some questions. I shall see you on Monday. Have a wonderful weekend. And remember, if nothing else gets through to you today, remember this message: maths is awesome. See you next week.